In the previous video, we learned about this idea called negative feedback, where you have an output, some kind of loop that feeds back into, for example, the negative part of the input, like this. And you can have some kind of component there, whatever that is, that maybe has some kind of factor. But the main idea is there is a loop, a feedback loop that goes like this. So the output will go back to the input, round and round and round. And there's two types of amplifier that use this idea of feedback. We are going to learn about the inverting, number one, and the non-inverting amplifier. So how can we use the idea of op-amps to create loops like this to control the gain and make an amplifier? Let's look at the first type of the inverting amplifier. So there's a purpose for this inverting amplifier, and that function, okay, this one you gotta know it for exam because they will ask you to define it. I wrote it up, I type it up here because down there I need space to draw the circuit. So the function of this amplifier is twofold. Firstly, you want to produce an output proportional to input. Output proportional to input. But secondly, more importantly, what makes this inverting amplifier different from the other one, the non-inverting, is that the output has opposite sign to the input. So there's a negative sign somewhere. So what does this mean? What is the output signal? What's the input signal? Let's take a look at the graph. So here I have with me a simulation of how the output and input could look like. Let's say I send an AC into the op-amp. This kind of inverting amplifier op-amp. You have an output 1 volt and an input 1 volt. I mean the peak is 1 volt. So I can change the input voltage and it'll be the same. I send in 4 volt, come out 4 volt. Why? That's because the gain is 1. What is gain? Gain is like the volume knob you control, the multiplier. So what if, let me bring this down again to 1. Okay. What if I change the gain to 2? Oh, you see something different now? Now when I send in a 1 volt signal, it comes out as 2. It's 2 times bigger. That is what we call a gain. Okay, the output comes out a little bigger and then the input. But remember, this is inverting. So what does inverting means? Inverting means instead of a gain of 2, you have a gain of negative 2. So I send in the blue signal, it comes out reverse. Ooh, that's just all. But it's times 2 lah, 2 times larger. 1 volt now become 2 volt. So that's what we mean when we send in a signal and a signal come out. And it's not going to go to infinity like the comparator circuit. No. Now we can actually control, fine-tune the gain. You want it big? Sure, we go big. You want it small? We go small. You want bigger? Okay, bigger. But it's a relationship between the output and the input, and they are the opposite side. Very important. This one, 1 volt go in, negative 2 come out. Remember, inverting means negative sign. The whole graph invert upside down. So how would the circuit look like if we that can create that kind of graph? You know, you send in something, it makes it bigger, but upside down, and send it out. Well, let's draw a circuit for this inverting amplifier. So we have the op-amp's output. I'm just going to draw this as V out. Here, V out. And we have the two op-amp inputs here and here. Now, how do we connect this? Firstly, I'm going to connect the positive to ground all the way down here. So this is our grounded. Okay. And this op-amp needs some power supply. So maybe I make a quick note to remind ourselves that, hey, it needs a power supply, okay? So this one is minus V supply. And the other one on top, positive V supply. Now this one is important because later there will be a trap here. Anyway, so how do we connect this feedback loop? We need an input. One is already grounded. Alright, so grounded there. It's going to be a 0 volt for our V plus input. So I'm going to use purple for voltage. There we go. Then the other one. Now this is where you got to do something new. We are going to connect a resistor on this end. So we're going to put a input to a resistor. And then out. Wow, this into shape makes great resistor drawing. So this is V in. Now how do you connect the feedback loop? There we try so many times. Feedback loop, negative feedback have to connect back to the negative one. So I'm going to draw a feedback loop right here. It's good to have feedback. So I'm going to put a green color to show that it's good. I'm going to draw a resistor here. This is the feedback resistor. And where does this go back? Well, it goes into the negative right here. All right. And of course, join at this point, go into the V minus input right here. Okay, so how does this work? Let's give some names to these resistors. The first one I'm going to call R in, resistor input. Now the special one and the very important one is going to be the feedback resistor RF, because it's part of the feedback loop in this top part here. Okay, this is all the loop. The output can go back into the input. Oh, okay. So we need to add more information here. What about the voltage and current? Is there any current flowing? I don't know, man. Let's go and see step by step. So we know that firstly, this V plus is connected to 0 volt, which is ground, earth or ground. So that means V plus is going to be 0 volt going inside here. So this one is 0 volt. Okay, so that means the output wants to stabilize between these two inputs. So the purpose of this feedback loop is to keep the V plus and V minus the same. Otherwise, the amplifier gain will be very big and then go to infinity now. So the feedback loop will say, hey, one of your input is 0, so please keep the other one 0. So whatever feedback happens here in this loop needs to ensure that V minus is also at 0 volt, because the other one is already ground. Okay, so no matter what happened, remember you want stability. The loop will tell you one of these is 0, the other one must also try to be 0. So you match V minus and V plus to be the same. So whatever feedback goes on, going to make sure that that is 0. Okay, let's do a few more example. Let's say I send in a positive input. I don't know, positive 3 volts, positive 5 volts, as long as it's positive. Where will current flow, you think? You see here is some positive voltage. Here is 0. Oh, so probably positive potential, and here is 0. That means current will flow from high potential to low potential, like that. This is what we call the input current. So this one, I'm going to put a name IN, because you're flowing from a high positive potential to 0 volt potential, which is this one. The loop will adjust so that it's 0 lah. Okay. Then, can current flow through the op-amp? No, current not supposed to flow through op-amp. It has very high impedance, or what you call resistance, but we call it impedance. So no current can flow through there. But the current say, wait a second, there's a loop here that I can flow. So if your V in is positive, the current will be like, woo, we have a loop. Okay, so current will flow up here through this feedback resistor. This is what we call the feedback current, IF. I'm going to call it that. And flow down to here. Why does current flow in this direction? Why doesn't it just stop? Because if your input is positive, sending into this one, then the op-amp will be like, here is a bit bigger leh. The negative, the V minus is a bit bigger. So the V out will become negative. And it says, no, don't do that, and send back feedback and say, please adjust it to become 0 volt. So you keep adjusting, trying to make this to be 0 volt so that they are the same. So when input is positive, output will be negative. That is called inverting lah. The in and out, opposite sign. Your input will be opposite sign to the output. So let's continue on here. This property of it lah, okay? One will be positive, one will be negative. So now we know current will be flowing from high to low potential, which is from positive to negative. Final thing is, I'm going to add some potential difference drawing. So hang on a second. We forgot to add potential difference. It will be important later. Now, when there's current flowing through a resistor, right, there will be potential difference between the ends of the resistor. This one, I'm going to name it V1. How about that? And the potential drop across the other one, I'll call it V2. I put it pink color because it's related to potential, but it's potential difference. Okay, so V in will be at some potential from ground. I don't know. Down here is 0 ma, so you go up by, I don't know, 4.5, positive 4.5, whatever that is. So that potential, okay, drop by a certain amount, go past the resistor. VR also have a certain potential, but it's negative lah. So you can talk about this as a negative V in, V out, sorry. for you to remember. So this is the whole picture of what is happening. You send an input. It may not be the same, but the output will feedback and keep trying to adjust the output so that V minus and V plus will be the same, because we want to be stable. We don't want saturation or any kind of infinite gain. Last few things to add. You notice 0 volt is earth, right? See, earth or ground is 0 volt. How come also got 0 volt up here in this point? This red dot right here. Now this is what we call virtual earth. I mean, earth is 0 volt. Why is there a 0 volt halfway in the circuit? Virtual earth law. So-called earth. Virtual earth. So this is an important idea that we will need to explain later. Why is it virtual earth? What is it called that? Last thing is a reminder. How do we know the current is flowing like this in this orange arrow? Because you are flowing from high potential to low potential. Like water, high up, you flow downhill, right? From high to low. So current behaves the same way. You flow from high potential to low potential. Now before you panic and like, oh my goodness, this circuit is so complicated, let me simplify a little bit for you on the right side. So what is happening here is actually just a potential divider. How to see? Why so many color miss? I draw for you. Potential divider. The op-amp is the potential divider. You see this? I highlight in blue. Can recognize or not? Can recognize? Never mind. I redraw for you on the right side. We have V in coming in here. Let's draw it here. Okay. V in. The first resistor, this is R in. The second resistor, this is RF. Then go to V out. Then where does the op-amp fit into this? I'm gonna move the op-amp a little bit to this side. Okay, you can bend the wires a bit in such a way so that the op-amp's legs are like this. Then the other one go to ground. You check and see both diagram is the same or not. You will have a virtual ground at this red dot. Okay, I just bend the wires a bit ma. This R in I bring it up, pull the wire up, so it become like this. So this one it's easier to see the potential difference lah. So when you have an input voltage V in, why red color suddenly? V in, and you have a V out on the right side, then you will have two potential drops. One drop over this one, V1, and another drop over this one, V2. Potential divider then suddenly halfway the op-amp will take it out. And this one, current flowing, if V in is positive, means V out must be negative because inverting amplifier. So current will flow from high to low. In between, don't forget, is 0 volt. Because the other leg is 0 volt, so you want to keep that as virtual earth. So this is a simplified version of this same diagram, but I straighten it so you can see, it's a potential divider. Two resistor there. One is the input for V minus. Okay, so how does this actually work? Let's see. Remember, the end of the day is to figure out what is the gain of this whole op-amp circuit thing. Okay, gain is your output, input, got some ratio, right? Okay, I remind you. From the previous section, we look at gain already. Gain is the output over input. So how do we find gain for this circuit? We just want to know the input times how many times then output. So, looks very complicated, but don't worry, stay calm. We can do this. Okay, so the first thing, we know the open loop gain is very large. The op-amp's gain is infinite, very, very large. But you don't want the op-amp to saturate. Hit maximum, then keep on become square wave. We don't want that. We talked about this in the feedback video previously. So, if op-amp is not to saturate, we don't want it to saturate, then you have a certain condition. You want your V plus and V minus to be the same. So I'm going to write here, V plus equals to V minus. Roughly equals to. Okay, and the feedback loop will ensure that this is true lah. So the feedback loop ensures this. That's the first thing. Okay, so then what? So we don't want it to saturate, so we make sure this one is roughly the same. The loop will just keep adjusting until it's the same. Stabilize there. So we don't want the gain, okay, number one. Then number two, what's the V plus input? 0 volt. So the other one will try to become 0 volt. So let's type that down. Since type down here. The non-inverting input, which is V plus, put in bracket lah, just for you to know. V plus is grounded. Grounded means what? 0 volt. See the 0 volt here? V plus connect to ground now. So grounded lor. Since this one is grounded, so what will the loop try to do to make sure the other one is there? So it will say, so V minus, or the inverting input. What is happening to my typing? V minus must be 0 volt 2. That's number 2. Gonna enter a space so we have more space to see. Okay, so first one, open loop gain is very large. And you don't want your op-amp to saturate. No, we want to control it. So V plus equals to V minus. This is the important thing. So I'm going to highlight. Oh, actually, I should highlight that. Yeah, sure. Why not? Then, one of it is 0. So the other one must also be 0. Okay, pretty good. But we still don't know how to use the equation and what is happening in the circuit up there. Okay, never mind. Next line. So, how to think of current? Just now I talked about it. Why current cannot go inside the op-amp? Because the impedance is large. So we're going to talk about that in the next part. Since the impedance of the op-amp is large, or very, very large, quite large lah. Resistance very high. Cannot easily let current go in. It's very large, so current cannot enter the op-amp. From there, we can already create an equation. We'll see why in a bit. Okay, so remember these 3 points. These are the main things. And they will ask you to define virtual earth with these 3 points. So these 3, explain, you must know what these things are. If you don't understand them, you just memorize this for now. It'll be okay. So from here, we can start an equation already. To derive the gain, remember what is gain? V out, V in. That's our ultimate goal. Can we find the gain of this circuit? Okay, we're going to end here. Current cannot enter op-amp. So you see, I label here I in and IF. Current come in here, goes to the loop and out. Can I start an equation with this? IN is the same as IF. Because when you come to this junction, no current is going into the op-amp. So this current IN is the same as IF throughout the whole loop. So I'm going to start as that first part. Okay, if you want to see the circuit, you refer to your notes lah. So number 1, I in equals to IF, which is the feedback current and the input current. Because the current didn't split, impedance is very large. So from there, I can create, or I use Ohm's law. Remember V equals to IR? But I want to do for current. So here, it will be V over R equals to V over R. But don't simply V over R. What is the V? What is the R? Let's look at the diagram. We look at this one, easier to see. That one very crowded now. Okay, so here is I in. This is IF. Wow, what is this sudden change in color? So you want to find the potential V. That will be I times R. Oh. You want to find I is V divided by R. VIR over resistor. So V1 over R in. So let's write that down. So the current will be V1 over R in. How about the one for feedback? This is the one for, not this one, feedback. Okay. So this one, feedback current will be V2 over RF. Okay. So V2 over RF is going to be the current. That's how you can calculate with Ohm's law. VIR. You VIR everything lah. So let's write there V2 over RF. V2 RF. Alright. But we want an equation for gain. There's no V in or V out anywhere in this equation. So we need to introduce what is V in and what is V out. So I'm going to redraw the circuit one more time here on the right side. This is the straightened version of it, and I'm going to assume that V in is positive. Let's for now assume it's positive. The other one is going to be negative. Opposite sign ma. So current will flow from high to low. Ding, 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 ding. And don't forget, the virtual ground is somewhere here in the middle where you will connect to the op-amp. Okay lah, if you want to draw the op-amp, it's like that lor. But no need to draw again lah, too many things already. Okay, so I just Just know that that one goes to the op-amp's V minus terminal. And there's virtual ground, which is 0 volt here. Okay, so what are we doing? V1 and V2. Alright, so V1 is the one over this. Now is there another way to express V1 in terms of V in and V out? V in is the potential. So the potential difference will be V in minus, on the other end, 0. Because here is V in, the other side is 0 ma. So the difference is V in minus 0. Okay, so let's expand this equation a little bit. So V1 now will be V in. Good news, now we have V in the equation. Okay, over R in. How about V2? V2 was the other side here, huh? We want to find potential difference. So you take high potential minus low potential. So 0 minus V out. Because 0 is higher than negative ma. So you take the high one minus low one, no? 0 minus V out. So we stick to that convention. Okay, let's write that out. So this one, V2 will be 0 minus V out over RF. Aha! I see it. Now we have V in, we have V out in the equation. So we can, next step, we rearrange everything so that we have the equation for gain. So gain will be V out over V in. All the R put on one side. So that will be negative RF over R in. Ta-da! We have an equation for gain. So this will give you, if you want to calculate the value for gain, this is the equation for it. V out over V in is your gain. Gain, we often use the symbol G lah. Okay, so one thing to note is this symbol, negative sign here. This will tell you that it is inverting. Your input is positive, your output will be a negative sign. So this one, just make a side note lah to remind yourself. V in and V out have opposite signs, so you can say that there is a phase difference of pi, or in maths we call it a vertical reflection. I will show you in a bit what that means. Vertical reflection. So the gain will be some negative number. Okay, first phase difference of pi. In physics, use the word phase difference of pi. I know in maths it means that. So in the graph, let's go back to the graph. If your gain is a negative number, let's say -1, okay, then your input graph will be like upside down of your output. This is also called a phase difference of pi. 180 phase difference, you shift the whole graph by pi. Okay, so this is what it means. Your input is like this, output is like that. And your gain will be negative. See the negative here? This negative means it's inverting. So no matter how you can change the output, but it will be inverted lah, upside down. Now you may say, Miss, but just now all the example, the input is positive. Like say for example, positive 1 volt. Then your output is, well, depends on what's the gain. Maybe negative 1 volt or more. What if V in is negative leh? Oh, same thing. Stay calm. If you send a negative volt input signal, then your output signal will be the inverting of it, positive. One negative, one positive. But now the current would have changed direction a bit. Okay, don't forget. This one is still going to be grounded. So this V minus, connect to V minus, is still going to be 0 volt right here. I shall use this one. Virtual earth is that red dot. But now where will current flow? Let's say one end is positive, I don't know, 4. The other end is negative 4. Which one is higher potential? Right side leh. So your current now will flow the other way, from high flow to low. Just so you know lah, okay? From high to low. Potential difference, everything still the same. So let's label this R in, RF. Okay, so just know that the current will flow the other way, and depending on which one is positive, which one is negative. So we can change the scenario. Now instead of sending a positive 1 volt here, see this positive 1 volt, we invert it. We send in a negative signal. Can send negative signal lah. I guess I could adjust this graph Send like this. So now I send in -1. My gain is -4. So my output will be -1 times 4 will be 4. Negative times negative. So -1, 4 times bigger, but inverted. So 4 times bigger, 4, but inverted. That's what a gain is. It's just you multiply by how much, that's your output already. Okay, so the whole circuit it boils down to this. But I need to warn you about something. The op-amp. Let's go back to original. Okay, let's say you have a input of 1 volt, gain of 4, -4. You can go as big as you want, the gain, but you must not exceed the power supply, otherwise you will hit the limit and saturate. So let's see what happens when we make the gain really, really big. Okay, I'll put the gain here. Let's go to -10. Okay. See, we make the gain very big. Bigger, 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 bigger. Then we hit the supply. What happened? Do you see what happened? Okay, let's make the supply smaller so you can see. Let's say the supply only 5 volts. The moment your output goes more than 5, we will get chopped off already. Because the maximum that your op-amp can output is the supply. You cannot go more than that. It's like the comparator circuit. Gain is infinite, so you just choose the power supply. 5 volt lah. Becomes square wave now. Square wave. Okay. So whenever your output is more than power supply, you just stick to power supply now. Cannot go larger now. This is the limit. The limit is 5. So you get chopped off. Cut off point. See? Vout -5. No matter how much gain you do. Okay, here say gain is -10. In theory lah. But your limit is 5, so you are stuck at 5 volt output. So just remember this point, be very careful. So if your input 1 volt, just a reminder, let's say your gain is pretty big. But you must be very careful of your supply, which is the limit, how high it can go. This is going to be Vsupply. So even if you have a super, super large output, you will get chopped off. And then go back down. Go up. Chop off. Come back down. So this one is your limit, your cut-off point. Saturate already. The op-amp saturate. So this will be your graph law. A bit squarish already. So write yourself a reminder that your Vout is limited by your power supply to the op-amp. What you give the op-amp in the first place. Okay. So let's go and see an example on how to apply this idea. A very quick one.